by emitting a same amount of energy. And what you do here, a type of confinement. आपका quantum dot है, इसमें ऊपर जाएगा नीचे आएगा फिर light निकलेगी. And from that basically you can make a single light source. ये आपका single photonic source which can be used for quantum cryptography. हम यूज करते हैं ना QR कोड एंड ऑल दिस थिंग. अभी तो हम उसको कैसे बनाते हैं, अटेन्यूएटर लेजर यूज करते हैं फॉर दैट, फॉर मेकिंग दैट. बट व्हेन यू हैव सिंगल फोटोनिक सोर्स द थिंग्स विल बी इवन मोर सिक्योर. ओके, सो दिस इज वन एप्लीकेशन. बट यस, दिस इज माय ओल्ड वर्क व्हिच आई एम गोइंग टू प्रेजेंट बिकॉज दिस इज क्वांटम नैनोस्ट्रक्चर and quantum nanostructure need a lot of sophisticated things, and also the data which we get might be a bit less, and we need quantity in publication and quality also. So I was working on that, didn't have any result for 2 to 3 years. Then one professor from CSR came, what is this, publication? Well, sir, actually data ही नहीं है. And then change the field. They said make the metal hydroxide by using chemical precipitation method, and see, and since then, yes, it worked fine. So that is basically nanostructure material that I do now. Okay, but let us see. Here we have electrochemical supercapacitor, again for a silicon. We use it as an electrode for supercapacity application, and we see the energy density increase by 10 to 40 times. And you can make surface enhanced Raman scattering substrate, because Raman signal is very weak, and we use stars and so on, and this can also be used for that purpose, because when you deposit some metal there is a resonance, and because of that you get higher signal as observed here. So these are the few applications, but before we start to work on porous silicon, using silicon, it is very necessary how to cut it and everything, what type of is. So you don't worry, it is already given by manufacturer. So depending on this cut, you know what type of it is, what is the orientation, and further you have to cut them parallel to this flat bend. Then only you can cut, otherwise you cannot cut. So this is already given. You take any silicon wafer, one of the cut will be there, and from that only you can know everything about that silicon wafer, what type of, what is the orientation, and so on. Okay, so this is the simple setup which I used to study quantum nanostructures. As you can see, it is a electrochemical cell. I have here in my department, I made this, and few of the BTech students work on that. Okay, and what we do, we take P-type silicon wafer, because hole is prerequisite to create pores into the silicon. So what we have here, silicon wafer. This is electrochemical cell. ये platinum है, act as a cathode, and on that you have aluminum plate, and then Teflon. This is made of Teflon, and this is a motor which can rotate your cathode for homogeneity of porous silicon into the silicon that you are making. And how it grows? So holes are there in the silicon, and when you apply, and you have HF-based solution. The another problem is you use hydrofluoric acid, and the smell of it is very dangerous for body, I tell you, because when I was in Germany working on porous silicon, a lot of silicon wafer I used to make, and they said you put mask and goggles, it is very uncomfortable for us people coming from, but I didn't wear. But what happens one day, I feel some vomiting type of problem, because I inhale a lot the hydrofluoric acid, and then I use mask and all these things, because it is very dangerous acid. If you put, it will go deep into your bones and so on. So that is why this is another reason that I means topic is good, but it's difficult to work, and you need to take a lot of precautions. Okay, so here is, you have holes in the silicon wafer. When you apply current, then the holes are basically accumulated on the pores, and it is captured by the chloride and in the solution. In that way, it grows deep into the silicon, and depending on the orientation, the pores will